Hello everyone and welcome to TalentSprint. Our discussion in this session will be on coordinate geometry, which is also known as analytic geometry. Here we study geometry with the help of a coordinate system. What is a coordinate system? Well, this is a system where we use a set of values or a set of numbers to uniquely locate the position of the point in the given plane or the given space. There are different types of coordinate systems, but the most commonly used one is the Cartesian system. In the Cartesian coordinate system, the plane is described with the help of two mutually perpendicular lines. And any point in this plane can be uniquely located with the help of two numerical values which are known as coordinates. And these values denote the distance of that point from these two mutually perpendicular lines. Let us understand in detail about the Cartesian coordinate system. So as I've mentioned, a Cartesian coordinate system is the one which is described with the help of two mutually perpendicular lines which are known as the coordinate axis or simply axis. So as we see here, there are two mutually perpendicular lines which intersect at a point O, which is known as the origin. The horizontal line indicates the horizontal direction of this plane and the vertical line indicates the vertical direction of the infinite plane. This horizontal line is known as the horizontal axis, right, which is denoted by x, o, x dash, and it extends up to infinity. Whereas the vertical line is known as the vertical axis, which is denoted by y, o, y dash, which again extends up to infinity. Right? So these are the two mutually perpendicular axes which intersect at the point O known as the origin. So what do we understand from these two lines? Here on both the perpendicular axes I have indicated only the integral values, that is +1, +2, +3 and so on, and -1, -2, -3 and so on. But in between 1 and 2 we again have infinite values which can be further denoted if required. Now as we see here, these two mutually perpendicular axes or the coordinate axis divide this plane into four different regions, right? Region 1, region 2, region 3 and region 4. And these regions are known as quadrants. So here we have got four quadrants. This is quadrant number 1, right? Quadrant 1. Here is quadrant 2. This is the third quadrant and here is the quadrant 4. Now what is the difference in each of these quadrants? If we observe in quadrant number 1, we find that we have got the positive x-axis and the positive y-axis. In quadrant 2, we have negative x-axis with the positive y-axis. The quadrant 3 covers the region which is described by negative x-axis and negative y-axis. Whereas the last quadrant, quadrant 4, covers the region described by positive x-axis with negative y-axis. Now as I've mentioned earlier, in the Cartesian coordinate system, we locate the position of any point with the help of coordinates, which are basically the distance of that point from the two perpendicular axes, right? Let's say there is a point P on this system, right? This is the point P. Now the location of this point is decided with the help of two coordinates which can be represented by an ordered pair. So x, y is known as an ordered pair. Right? So these are actually two numerical values. Now what does these two values indicate here? The distance of the point P from x-axis and y-axis, or the horizontal distance and the vertical distance of the point P. Right? For example, let's take the point P here. If you observe, when we try to map it to y-axis and x-axis, where does it meet? Right? Let's take this. So what do we see? The point P, when you try to draw a line from point P towards y-axis, it meets 4, and when we draw a perpendicular on x-axis, it meets 0.5. So we see that the distance of the point P, the horizontal distance of the point P is 5, right? From 0 it is up to 5. So x is equal to 5. Whereas the vertical distance of point P is 4, right? The vertical distance of point P from x-axis is 4. So y becomes 4. So we can say that the point P here is described by the order pair 5, 4, where 5 is the distance of the point from y-axis, which is the horizontal distance, and 4 is the distance of the point from x-axis, which is nothing but the vertical distance. So this is known as an ordered pair, and the values x and y are called as coordinates. Specifically, x here is known as abscissa, or we can say the horizontal distance is known as abscissa, whereas the vertical distance y is known as ordinate. Right? So this is how we can describe the location of a point, or this is how we can locate any point in the Cartesian coordinate system. Now if you observe, both the coordinates in quadrant number 1 represent positive values, because the quadrant 1 is described by positive x-axis and positive y-axis. So here we'll find that always the ordered pair will have positive values, both the values are positive. Now what happens in case of quadrant 2? Since it is described by negative x-axis and positive y-axis, the ordered pair will have negative and positive values respectively. So if we take any point in the quadrant 2, the abscissa will be a negative value, right? And ordinate will be a positive value. Likewise in quadrant 3, as it is described by both negative x-axis and negative y-axis, the ordered pair will have negative values, both the values will be negative. And in quadrant 4, positive x-axis with negative y-axis. So any point in this plane can be described simply with the help of an ordered pair, right, which is giving us the distance of that point from both the mutually perpendicular axes. And the origin of this coordinate system, which is nothing but the intersection of both the mutually perpendicular axes, is described by an ordered pair 0, 0, right? Because the point O, the origin here, is at a distance of 0 units from x-axis and 0 units from y-axis. Likewise, let's say if you have to talk about this point, right? Here is a point. What do we see? That this point is at a distance of 2 units from y-axis, which is the horizontal distance, and at a distance of 0 units from x-axis. It falls on x-axis, so the ordinate will be equal to 0. If we take a point on y-axis, let's talk about this point. This point can be described by 0, 6. What does 0 indicate? The distance of the point from y-axis, which is the horizontal distance. Understand, horizontal distance is always the distance from y-axis. Vertical distance is the distance from x-axis. So what is the horizontal distance? 0, right? It is on y-axis. The horizontal distance of this point from y-axis is 0. Whereas the vertical distance, the distance from x-axis is 6 units. So we can say that the point is described by 0, 6. And likewise in any other quadrant, we can find out the location of a point with the help of the two coordinates, right? Abscissa and ordinate respectively. So before we move on to the next part, let's quickly look at the location of a point in each of the remaining quadrants as well. For example, in quadrant 2, let's say we are looking at a point which is, the intersection of these two lines, right? So this is the point P here, right? Or let's take this point as M, right? Now, what will be the coordinates of the point M? The horizontal distance. What is the horizontal distance? The horizontal distance is -4, right? So the point can be described by -4. And the vertical distance. What is the vertical distance of this point? 3. So -4, 3. Likewise, let's say we have, some point in quadrant number 3, right? If you look at the intersection of these 2 points, right? Let's take the point as N. Now how can this point N be located? We can say the horizontal distance is -5, whereas the vertical distance is -1. Understand, we are coming below the origin on the y-axis, which is described by negative y-axis. So -5, -1. And likewise in quadrant 4, let's say there is a point R, right? Point R, which is, right, this is the point R, let's say. Now what will be the coordinates of the point R? The horizontal distance is 3 + 3, whereas the vertical distance is -6. So it can be taken as 3, -6. And as we have learnt earlier, you see that the coordinates in quadrant number 1 will be positive, right? Both are positive, plus and plus. The coordinates in quadrant 2 will be negative and positive, so -4 and +3. In quadrant 3, both will be negative, so -5 and -1. Whereas in quadrant number 4, positive x-axis, so +3, and negative y-axis, so -6. This is how we can locate the position of any point in the Cartesian coordinate system with the help of an ordered pair, right? That is x, y, where x denotes the distance of the point from y-axis, which is the horizontal distance, and y denotes the distance of the point from x-axis, which is the vertical distance. Alright, so the important point to be noted here is, in the ordered pair, abscissa, what is abscissa here? X, right? That x denotes the distance from y-axis, right? Distance from y-axis or the vertical axis, whereas y, that is the ordinate, denotes the distance from x-axis. So distance from y-axis is the horizontal distance and distance from x-axis is the vertical distance. Alright, so let's say, if the question says what is the horizontal distance of the point 5, 4, the horizontal distance is 5, or the distance from y-axis is 5. What is the distance from x-axis? 4. In this case, what is the distance from y-axis? The distance from y-axis is 4. See, actually it is -4, but minus only indicates that it is on the second quadrant. It is in the second quadrant. But the distance in terms of magnitude is 4. So the distance from y-axis is 4. The distance from x-axis is 3. Alright, what is the distance from y-axis? It is 5, and -1 is the distance from x-axis. And likewise in the last quadrant here, the distance from y-axis is 3, right? From y-axis, the horizontal distance is 3, and the vertical distance, that is the distance from x-axis, is 6. -6 indicates it is below the x-axis. 6 is the magnitude, which shows the distance from x-axis. And also we can observe that if there is any point which is on the x-axis, like in this case the point denoted by 2, 0, right? The point on x-axis will always have an ordinate equal to 0. Why is it so? If the point is on x-axis, its distance from x-axis will be 0. Right? Ordinate y is the distance from x-axis. Now since the point is on x-axis, its distance from x-axis is 0. So it is very important to note that any point which is on x-axis will have an ordinate equal to 0. And in similar terms, any point which is on y-axis will have an abscissa equal to 0. Yes or no? If you look at this point, it is on y-axis. What does x indicate? What does the abscissa indicate? The distance from y-axis. Now since the point itself is on y-axis, its distance from y-axis will be 0. So abscissa is 0 for a point on y-axis. Ordinate is 0 for a point on x-axis. And the intersection of these two axes is denoted by the origin, which is 0, 0. Right? Now if you observe this particular point, the origin denoted by O is on both x-axis and y-axis, since it is the intersection, right? The two lines meet at that particular point. Now this point here falls on x-axis and also on y-axis. So both ordinate and abscissa are 0. So it can be denoted by 0, 0. Let us now look at the first model from this topic of coordinate geometry, where we shall see how to calculate the distance between two given points. Let us look at the given statements here. We have 4 statements. The first one says the distance between 2 points A, which is described by x1, y1, and B described by x2, y2 in the xy plane. What is an xy plane? A Cartesian plane, is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. So we simply need to take the square of the differences of abscissa plus the square of the differences of ordinates under root to get the distance between the 2 points. The second point here says that the distance of a point A, where the coordinates are x, y, from the origin in the xy plane can be simply taken as root over x squared plus y squared. Now, a very simple point. Since we are calculating the distance from the origin, in the origin the coordinates are 0, 0. So what happens? The second point in our first statement becomes 0, 0, right? So x2 is 0 and y2 also is 0. So what do we get? x1 squared plus y1 squared under root. That is nothing but x squared plus y squared under root. So when we have to measure the distance from the origin, simply take root over x squared plus y squared, where x and y are the coordinates of the point A. The next point says that the distance between the points A, x1, y, and B, x2, y, is equal to modulus of x2 minus x1. Now what do you observe here? We have got 2 points A and B. The point A is having the coordinates x1 and y, and the point B has the coordinates x2 and y. What do we see? The second coordinate, which is known as the ordinate, in both the points is same. That is, the vertical distance of both the points is same, or the distance from x-axis of both the points is same. In that case, y2 minus y1 whole squared becomes 0. y2 minus y1 is 0. 0 squared 0. So what are we left with? Root over x2 minus x1 squared. Again squared and under root gets cancelled. Simply we are left with x2 minus x1. So that is what we take here, x2 minus x1, and modulus sign, because we may get a negative value, but the distance should be a positive value there, right? So we simply neglect the sign and only consider the magnitude. So the distance between 2 points which have got the same vertical distance or same distance from x-axis can be taken as the difference of their abscissa, right? Or x2 minus x1. And likewise, the distance between 2 points which are x comma y1 and x comma y2 can be taken as modulus of y2 minus y1. The same argument holds true for statement number 4 as well, right? Since the horizontal distance are same, right? X and x is the horizontal distance. Now the horizontal distance of both the points is same, which means the distance from y-axis is same for both the points. So we can simply take the distance between the 2 points as modulus of y2 minus y1. So the basis of calculating the distance between any 2 points is root over x2 minus x1 squared plus y2 minus y1 squared. Let us now take the first example from model 1, which is about calculating the distance between 2 given points. The question here is, if the distance between 2 points 0, minus 5 and x, 0 is 13 units, then x is equal to what? So as you see here, we have got 2 points. First one is 0, minus 5 and the second one is x, 0. X is the variable there, unknown value. The distance between these 2 points is given as 13 and we need to find out the value of x. Now we very well know that the distance between 2 points can be calculated as root over x2 minus x1 whole squared plus y2 minus y1 whole squared, right? This will give us the distance between the 2 points. Let us just substitute the given values. So what is x1? 0, y1 minus 5, x2 is x and y2 is 0. The distance is given as 13 units. So let us substitute the values. x2 minus x1, that is x minus 0. X minus 0 squared plus y2 minus y1. What is y2? 0 minus y1. y1 is minus 5. So 0 minus of minus 5 whole squared equals to the distance is 13. So what do we get? This implies root over x squared plus 5 squared, 25 equals to 13. Now by squaring on both the sides, we get x squared plus 25 equals to 169, which implies x squared will be 169 minus 25, that is 144. Now if x squared is 144, what will be the value of x? It will be plus or minus 12. Remember, do not commit a mistake here by saying that x is equal to 12. X squared is 144, so x can take plus 12 or minus 12. So we can say that the answer for this question, that is the value of x, will be equal to plus or minus 12. So a very simple application of the distance between 2 points. And this is one of the earlier SSC CHSL exam questions. Let us now look at the second example from model 1, which also happens to be an earlier SSC CHSL exam question. It says, what is the distance between the points 0, 0, that is the origin, and the intersecting point of the graphs of x equals to 3 and y equals to 4. Now it may sound a little complicated, but then when you actually solve it, you will find that this is a very simple question, right? We have to find out the distance between 2 points, right? We know that it can be taken as root over x2 minus x1 whole square plus y2 minus y1 whole square. Now one of the points is origin, and we also understand that when one of the points is origin, or we are calculating the distance of a point from the origin, it is simply root over x square plus y square. But what is the other point? The other point is the intersecting point of the graphs of x equal to 3 and y equal to 4. So we'll actually have to look at the graphs of these two equations, x equal to 3 and y equal to 4. Well, that's not really difficult to understand. Let us take the coordinate system, right? This is the x-axis and here we have the y-axis with the origin at this place, right? The intersection here is the origin. Now it says x is equal to 3. What do you mean by x equals to 3? We have to draw the graph x equal to 3. Now x is equal to 3. We know that this is like different points on x-axis, 1, 2, 3 and so on. So x equal to 3 will be at this point, right? This is like 3, 0, x equals to 3, y equals to 0. And y equals to 4. What happens? This is 1, 2, 3 and 4. So y equal to 4 implies it falls on y-axis where x is equal to 0 but y is equal to 4. Now we need to find out the intersecting point of the graphs. Understand, we have not drawn the graphs yet. We have only looked at the points where it meets on x and y axis respectively, right? X equals to 3 meets at 3, 0 on x axis, and y equals to 4 meets at 0, 4 on y axis. Now what do you mean by a graph? It will simply be a straight line, right? X equal to 3. So if you draw a line like this is the line which denotes x equal to 3, right? The distance of this line from y axis, the horizontal distance, is 3 units. Likewise, the distance of this line y equals to 4 from x axis is how much? 4 units. So this is 4 and this distance here is 3. So this line indicates x equal to 3. Alright, and this horizontal line here indicates y equals to 4. We'll probably understand this much better when we look at the equations of straight lines. However, considering two simple equations, x equal to 3 and y equals to 4. What is the point of intersection? This is the point of intersection. Let's say P, the point of intersection P. And what will be the order pair for that point P? It will simply be 3, 4. Yes or no? This point will be 3, 4. 3 units from y-axis, the horizontal distance, and 4 units from x-axis, the vertical distance. 3, 4, which is the basis of the Cartesian coordinate system. Now we need to find out the distance between origin and this point P, which is this distance. Alright, we have to calculate this distance d here. We know that the distance of any point from the origin is simply root over x square plus y square, right? The point here is 3, 4. So what will be the distance from origin? It will be equal to root over 3 squared plus 4 squared, which is 5, right? 9 plus 16 is 25, under root 25 is 5. So 5 units will be the distance of the intersecting points of x equal to 3 and y equal to 4 from the origin O. So this is how we can draw the graphs for the equations x equal to 3 and y equals to 4, which are really simple to find out the point of intersection and then calculate its distance from the origin O. Let us now look at the second module from this topic of coordinate geometry, where we shall learn about the section formula, which is basically calculating the coordinates of a point that divides a line segment joining two other points in a given ratio. Let's look at the statement first. It says if any point P of x, y divides the line segment joining the points A, x1, y1 and B, x2, y2 in the ratio m is to n. Now there are two cases. It may divide in the ratio m is to n internally or externally. So what happens when a point P divides a line segment joining two other points A and B in the ratio m is to n internally? The point P can be calculated as P of x, y equal to mx2 plus nx1 by m plus n, and the y coordinate will be equal to m by 2 plus ny1 by m plus n. So basically the point P, or the coordinates of the point P, will be mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. So what do we understand from the statement here? Let's say there are 2 points A and B, right? These are the 2 points A and B. So there is a line segment joining these 2 points, alright? Line segment joining these 2 points. So this is the line segment AB. Now there is a point P, let's say the point P is here, right? The point P, which divides this line segment in the ratio m is to n internally, right? So this ratio of division here is m is to n. So this is m, this segment is equal to m, and the remaining part is n. So basically it means the distance PA, the distance between the points PA divided by the distance between the points PB will be in the ratio m by n. In such a case, we can calculate the coordinates of P using the given formula, mx2 plus nx1 by m plus n, m by 2 plus ny1 by m plus n. And in the case, let's say, where P divides the 2 points, or the line segment joining the 2 points in the ratio m is to n externally, then the coordinates of P can be calculated as mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. So the only difference is plus becomes minus when it divides in the ratio m is to n externally. So these will be the coordinates of the point P. Now how do you understand this graphically, division of a line segment joining A and B in the ratio m is to n externally? Let's look at it. Let's say the 2 points are A and B, like in the earlier case. These are the 2 points and the line segment joining these 2 points. Alright. Now P is a point which lies elsewhere, right? This is not on the line segment A and B. It divides A and B in the ratio m is to n externally. In that case, what do? Let's say the point P is here. Now if you understand the point P to the point A, this distance, and point P to the point B, this distance will be in the ratio m is to n. This is m and this is n. Are you able to follow? So the distance from P to A is m and the distance from P to B is n. So again we say PA by PB equals to m by n, right? P to A, this distance is m units, and P to B, the distance is n units. So PA by PB equals to m is to n. So similar to the earlier case, PA by PB equals to m is to n, but the difference is here P was on the line segment between the points A and B, and in this case P is outside the line segment joined by the 2 points A and B. So simply understand that the coordinates of such a point will be mx2 plus or minus nx1 by m plus or minus n, my2 plus or minus ny1 by m plus or minus n, plus if it divides in the ratio m is to n internally, and minus if it divides externally. Now the other point which we can understand from this statement here is, let's say in this case when P divides in the ratio m is to n internally, P is the midpoint, right? The statement says, or the given question says, that P is the midpoint of the line segment which is joined by the 2 points A and B, right? So there is a line segment formed by the 2 points A and B, and P is the midpoint of it. If P is the midpoint, what does it mean? It falls exactly between A and B. It lies exactly between the 2 points A and B. In that case, m and n, or m is to n, will be equal to 1 is to 1. Yes or no? If it is a midpoint, PA by PB will be equal to 1 by 1, right? PA by PB will be equal to 1 by 1. The ratio will be 1 is to 1, right? It is a midpoint. In that case, what happens? How can you calculate the coordinates of P? Just substitute m equals to 1 and n equal to 1. So 1x2 plus 1x1, which is basically x2 plus x1, divided by 1 plus 1, 2. And likewise, 1 into y2 plus 1 into y1. So y2 plus y1 divided by 1 plus 1, 2. So in that case, we see that P is the midpoint, right? P is the midpoint, where the coordinates, if P is the midpoint, the coordinates P of x comma y will be equal to x1 plus x2 by 2 and y1 plus y2 by 2. So this is one simple point which can be understood from the section formula, right? If it is a midpoint, the ratio is 1 is to 1, and if the ratio is 1 is to 1, the coordinates will be x1 plus x2 by 2 and y1 plus y2 by 2. Let us now take an example based on the section formula. The question says, find the point that divides the line segment joining the points 4, 5 and minus 4, 1 in the ratio 1 is to 3, internally and externally. So we have to find out two different points here. One where it divides the line segment joining these 2 points in the ratio 1 is 3 internally, and 2 where it divides in the ratio 1 is 3 externally. Now we have the section formula for finding out such points. So let's look at the first one, right? Let's say the point here is P of x comma y, right? And the formula is mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n, right? This is the formula for the point dividing the line segment in the given ratio internally, right? So let's substitute the values now. mx2, this ratio here is 1 is 3, which is nothing but m is to n. So mx2, right? This is x1 comma y1, and here is x2 comma y2. So we have all the values, just need to substitute and do the calculation there. So mx2, 1 into minus 4 is minus 4 plus nx1, 3 into x1, 4, 3 into 4, 12 divided by m plus n, 1 plus 3 is 4, and my2, so 1 into 1 is 1 plus ny1, 3 into 5 is 15 divided by m plus n, which is 1 plus 3. Now what do we get on simplification? Minus 4 plus 12 is 8, 8 by 4 is 2, and 1 plus 15 is 16, 16 by 4 is 4. So the point that divides this line segment in the ratio 1 is 3 internally is 2, 4. And let's now look at the point which divides it externally, right? What is the formula? The point can be taken as mx2 minus nx1 divided by m minus n, and my2 minus ny1 divided by m minus n. So I think let me just put it here. This can be taken as 2, 4. Let's look at the second calculation. So mx2, 1 into minus 4 is minus 4, and y2 3 into nx1, right, 3 into 4 is 12, right? So minus 12 divided by m minus n, 1 minus 3, comma the next one, and if you actually look at it, my2, ny1, the magnitudes are anyway going to be the same, right? Like in this case, if you see mx2, so minus 4 and minus 4, nx1, 12 and 12, plus and minus depending on internal or external division, right? However, if it is a direct question, we have to do the calculation as follows. So my2, what is my2? 1 into 1, which is 1, ny1, 3 into 5, 15, minus 15 upon 1 minus 3. Now simplify this, what do we get? Minus 16 by minus 2, right? 1 minus 3 is minus 2. Minus 16 upon minus 2. Minus and minus gets cancelled. 16 by 2 is 8. And 1 minus 15 is minus 14. Minus 14 upon minus 2 is 14 by 2, which is 7. So that point here would be 8, 7. So simply substitute the values in the given formula and arrive at the required answer. Likewise, let's say if the question says find the point that is the midpoint of the line segment joining these 2 points, or what will be the midpoint of the line segment that join these 2 points. What do? You should take x1 plus x2 by 2 and y1 plus y2 by 2. So that midpoint, in case if required, can be calculated as x1 plus x2 by 2. So 4 minus 4 minus 4 by 2, and y1 plus y2 by 2, 5 plus 1 by 2, 5 plus 1 by 2, which is equal to, this is 0, and 5 plus 1 by 2 is 3. So 0, 3 will be the midpoint of the line segment joining the points 4, 5 and minus 4, 1. So this is how we can easily answer the questions based on the section formula. One of the most important parts of this topic is the different forms of equations of a straight line. But before we get into that, we need to understand what is meant by slope of a straight line and how do we measure this. Let us understand this with the help of a simple illustration. So as we see on the board here, we have got the two mutually perpendicular coordinate axes, the x and the y axis, which intersect at the origin O. And there is a straight line at some angle of inclination. So how do we measure the slope of this line? Well, slope is also known as gradient. It can either be called slope or gradient. So just be clear with the terminology. It can be called as slope or gradient, and it is denoted by the letter M. Alright. Now slope of a straight line can be measured as tan theta. M is equal to tan theta or tangent of theta, which is the trigonometric ratio, right? So M, or the slope of the line, can be taken as tan theta. Now what is theta here? Theta is the angle of inclination made by the straight line with x-axis, right? So if you observe, there is some angle between x-axis and the straight line, right? So this angle, when measured in the anti-clockwise direction, let it be equal to theta. So the slope of the straight line can be taken as tan theta, where theta is the angle between the straight line and the x-axis. And remember that the angle here is measured in the anti-clockwise direction from the positive x-axis. So M, or slope, is equal to tan theta. As simple as that. What is the other way of calculating the slope? Well, let's assume that the straight line passes through 2 points A and B. Right? So let the point A be at this position and this be the point B. Alright, so the straight line passes through the 2 points A and B, where the coordinates are x1, y1 and x2, y2 respectively. Alright, now if at all the 2 points through which the straight line passes through is given to us, then the slope can be taken as y2 minus y1 divided by x2 minus x1, where y2 minus y1 is the difference of y coordinates of the 2 points, and x2 minus x1 is the difference of x coordinates. So the difference of ordinates by the difference of abscissa, right? So the slope of the straight line or gradient of a straight line is equal to tan theta, which is equal to y2 minus y1 by x2 minus x1. Now, how do we get this equation y2 minus y1 by x2 minus x1? It's very easy to understand. If you look at the 2 points A and B, which are marked as shown here, and the coordinates x1, x2, y1, y2, we see that the straight line here with respect to x-axis, as we have seen, makes an angle of theta. Alright, the angle theta here will be same, because anyway these two are parallel lines. The x-axis is just, let's say, shifted upwards, right? So the angle theta remains the same. Now if you look at the coordinates x1, y1, x2, y2, what do we see? Let's look at this vertical distance, right? So if we drop a perpendicular here, what is this? This is y2, right? The vertical distance of point B is y2, and point A, right? The vertical distance is y1. Are you able to follow? This vertical distance here is y1. If this is y1, this also would be equal to y1. Alright? And the complete distance is equal to y2. This is equal to y2. So what is the distance between this straight line and the point B? It will be equal to y2 minus y1. Alright? This dotted line can be measured as y2 minus y1. That is the total distance minus y1. Likewise, this portion here, that is the horizontal distance, can be taken as x2 minus x1. Are you able to follow? Because the horizontal distance of point B is x2, right? From y-axis, horizontal distance is the distance from y-axis. So from y-axis, the point B is at a distance of x2 and the point A is at a distance of x1. So we can say that from this point to this point, the difference is going to be x2 minus x1. Now what is tan theta, the trigonometric ratio tan theta? It is opposite side by adjacent side. In a given right angle triangle, tan theta can be taken as opposite side by the adjacent side. Now in this right angle triangle, right, BA, and let's say this point here is C. In this right angle triangle BAC, what do we see? Tan theta will be equal to opposite side. The opposite side is y2 minus y1 and the adjacent side is x2 minus x1. So that is the reason the slope can be measured as y2 minus y1 by x2 minus x1, where x1 y1 and x2 y2 are the coordinates of the 2 points A and B through which the straight line passes through. And it can be any 2 points on the straight line, right? So once we know the 2 points through which a straight line passes through, we can simply measure the slope as y2 minus y1 by x2 minus x1. And if the angle of inclination from the x-axis is given to us, then it can be taken as tan theta. So this is what is meant by slope or the gradient of a straight line. Now that we have learned what is meant by slope of a straight line and how to measure it, let us look at the different forms of equations of a straight line. And we shall start with the general form of equation. But let us first understand what is meant by an equation of the straight line. Well, an equation of a straight line is a relationship between x and y, which is satisfied by the coordinates of each and every point that lies on the straight line. We know that a straight line passes through a number of points. So an equation should be the one which is satisfied by the coordinates of all those points which lie on the straight line. Let us look at the general form of the equation. So as you see here, the general form is ax plus by plus c equals to 0. Right? It is a simple linear equation in terms of two variables x and y, and a, b and c are the coefficients. So x and y are the variables and a, b, c are the real coefficients. So this is the general form of equation of a straight line, or a simple linear equation in terms of x and y. Now the slope of the straight line can be determined from the equation of the line, right? If we know the equation of the line, or if the equation of the line is given to us, we can find out the slope of the straight line without doing any sort of calculation. Let's look at how do we do that. Now, slope of a line is equal to minus of the coefficient of x divided by coefficient of y, where x and y are the variables. Right? So if you look at the general form, it is ax plus by plus c equals to 0. So we can say the coefficient is minus a by b, where a is the coefficient of x and b is the coefficient of y. So if we have a linear equation, which is the equation of a straight line, we can say the slope of the line is minus a by b. It is equal to m, right? In general, we denote the slope as m. So m can be taken as minus a by b. Now, apart from the general equation of a straight line, or the general form of equation of a straight line, there are a few important equations which we need to understand clearly. Let's have a look at them. For example, the equation of x-axis. What will be the equation of x-axis? Now, x-axis is also a straight line. Yes or no? Out of the two coordinate axes, the horizontal axis is x-axis, which is nothing but a straight line. So what is the equation of x-axis? Right. The equation of x-axis is y equals to 0. Y equal to 0. As simple as that. Now why do we say the equation of x-axis y equal to 0? Because on x-axis the y coordinate is always equal to 0, right? Y coordinate denotes the vertical distance of the line from x-axis. For x-axis the vertical distance from x-axis is 0, hence y equals to 0, and that gives us the equation of x-axis. Let us understand this with the help of the coordinate axis, right? Let's say these are the x and y axis respectively, right? Mutually perpendicular axis meeting at the origin O. Now we are looking at the equation of x-axis, right? The equation of x-axis will be simply y equal to 0. It can be taken as y equal to 0 because the y coordinate of any point on the x-axis will be 0. The vertical distance is 0, right? Vertical distance, which is y coordinate, is 0. So y equal to 0 gives us the equation of x-axis. What about the slope of x-axis? We know that in general form the slope is minus a by b. What about the slope of x-axis? Now if you look at it, we have got no x variable at all, right? There is no x variable here, right? We don't have the x variable. Now the coefficient of the slope of a line can be taken as coefficient of x by coefficient of y. What is the coefficient of x? 0. Hence the slope of x-axis can be taken as 0, right? So the slope of x-axis will be equal to 0. There is another way to understand why the slope is 0. We have understood that slope is tan theta, where theta is the angle made by the line with x-axis. Now for x-axis, what is the angle made by x-axis? 0. Right? What is the angle of inclination? 0. There is no inclination for x-axis with x-axis, right? It is one and the same. So angle is 0, which is tan 0. Tan 0 is equal to 0. Hence we can say the slope of x-axis is 0. So the equation is y equal to 0 and the slope is equal to 0. How about the equation of y-axis? Now this should be easy. Since we have learned what is the equation of x-axis, equation of y-axis should be simple. Equation of y-axis is x equal to 0. Now why do we say the equation is x equal to 0? Because on y-axis the x coordinate is always 0. You take any point on y-axis, x coordinate will be equal to 0. So a simple equation here is x equal to 0, right? What is x? X coordinate is a horizontal distance. Now what is the horizontal distance of y-axis? 0, right? There is no horizontal distance. It is the y-axis itself. Hence the horizontal distance is 0, which means x equal to 0. And now let's look at the slope. What is the slope of y-axis? Well, the slope of y-axis is undefined, right? Slope here is undefined. We cannot talk about the slope of y-axis. What is the reason? Understand, if you go by the theta, tan theta there, we know that y-axis makes an angle of 90 degrees with x-axis. So theta is equal to 90. But what is tan theta? Undefined, right? So slope of y-axis should be taken as undefined. Or if you go by the formula here, we know that it is coefficient of x by coefficient of y. Negative of coefficient of x by coefficient of y. What is the coefficient of x? 1. What is coefficient of y? 0, right? There is no y variable here. So 0. So minus 1 by 0. What is 1 by 0? It's undefined. So slope here is undefined. So that's about the equation of the coordinate axis. X-axis y equal to 0 with a slope of 0, and y-axis x equal to 0 with a slope which is undefined. Let us also look at the equation of lines which are parallel to x-axis and y-axis, right? Let's say a line parallel to x-axis. Any line that is parallel to x-axis. What will be the equation? Right? Equation of a straight line which is parallel to x-axis. So we have seen the equation of x-axis is y equal to 0, equation of y-axis is x equal to 0. Now let's look at a line which is parallel to x-axis. So these two lines will never meet each other. There is a distance. There is a constant distance between these two lines. Let us assume that distance is k, right? The distance here is k. Now how do you get the equation of this line? See, for x-axis the equation is y equal to 0. Because the y coordinate is 0, right? The vertical distance is 0. But for this line, what is the vertical distance? It is k, right? It is k units. K is the distance of the line from x-axis. So we can say the equation of a line parallel to x-axis will be y equals to k. Yes or no? So this can be taken as y equal to k. And slope, however, would remain 0, right? Slope of x-axis or any line parallel to x-axis is 0. Because even this line, which is parallel to x-axis, makes an angle of 0 degrees, right? What's the angle here? Theta, 0. Theta is 0, tan theta will be 0. So the slope will be 0, right? So the line parallel to x-axis can be given by y equals to k, where k is the vertical distance, right? K is nothing but the y coordinate or the vertical distance of the line from x-axis. Now a line parallel to y-axis, line parallel to y-axis, and since we have already looked at a parallel line to x-axis, this shouldn't be difficult. What do we do? X equals to k, x will be equal to k, and slope undefined, right? So for example, let's say there is a line which is parallel to y-axis. Let's look at this line, right? It is parallel to y-axis. So there is a constant distance between y-axis and this line. Let that distance be k, some constant k, or you can take any other constant there. So the distance is k. So what will be the equation? See, y-axis x equal to 0, right? On this line x will be equal to 0, but this line is cutting x at what point? At k. Like the earlier case, this line parallel to x-axis was cutting y-axis at a point k, and likewise this line here is cutting x-axis at a point k. So we can say the equation of this line is x equals to k, right? So for y-axis x is 0, and for any line which is parallel to y-axis, x equal to k will be the equation. So we can say x equal to k is the equation, and slope remains undefined. Why? This line is making an angle of 90 degrees with x-axis, tan 90. Undefined, right? Or simply we know that the slope of a line is coefficient of x by coefficient of y. What is the coefficient of x? 1. Coefficient of y? 0. 1 by 0, undefined. So simply go by either the formula, which is minus of coefficient of x by coefficient of y, or tan theta, and these represent the general form of equation of a straight line. Having learned the general form of equation of a straight line, let us now look at the other various forms in which a straight line can be represented. And we shall start with the slope-intercept form. So let's understand what is meant by slope-intercept form. Right? Now in this slope-intercept form, we are given the slope of the line and the y-intercept. In that case, the equation can be taken as y equals to mx plus c, right? Where m is the slope of the line and c is the intercept that is cut off by the line on y-axis. Now, what is an intercept? Let's understand this with the help of a simple graph. Let's say these are the coordinate axes, the x and the y-axis, right? And we have a straight line as follows. Now the slope of this straight line is given as m. The slope is m. And the y-intercept is c. What is meant by intercept? Well, intercept is nothing but the distance between the origin and the point where the line cuts on the given axis. Like in our case, we say that y-intercept is c, right? Which means, let's say the line here cuts y-axis at this point. So the distance between origin O and this point of intersection of the line with y-axis is known as the y-intercept, which is given as c. So once the y-intercept and the slope is given, the equation of the line can be taken as y equals to mx plus c. So m is the slope and c is the y-intercept, and x and y are the variables. This also is at times referred as the general form of the equation of a straight line, right? It can be compared with ax plus by plus c equals 0. Let us now take the next form, that is the slope point form. Let us see how do we represent a line in the slope point form. Like in the earlier case, we know that the slope-intercept form can be taken as y equals to mx plus c. So the slope and the intercept were given to us. And in this case, when the slope and the point through which the line passes through is given, then we can take the slope-intercept form, which is given as y minus y1 equals to m into x minus x1. Let's say the question says that a line passes through a point x1, y1 and its slope is m. Then the equation of the line can be taken as y minus y1 equals to m into x minus x1. So instead of giving the y-intercept, we are given a point. Let's say a point A, the coordinates of which are x1, y1. So if the point A and the slope is given, then we go ahead with slope point form, which is y minus y1 equals to m into x minus x1. Alright. Let us now take the next form, which is two-point form. Two-point form. So as the name says here, instead of giving the slope, we are given 2 points through which the line passes through. Right? Earlier in the slope-intercept form, we are given the slope and the y-intercept. In slope point form, the slope and a single point. But in 2-point form, we are given 2 points through which the line passes through. and we need to find out the equation, which can be taken as y minus y1 equals to, now it should be similar to slope point form, right? Equation is y minus y1 equals to m into x minus f1. So y minus y1 equals to m. Now what is m? Slope. We know how to measure the slope of a line when 2 points are given. How do we take it? y2 minus y1 by x2 minus x1. So m can be replaced with y2 minus y1 divided by x2 minus x1 into x minus x1. So if you look at slope point form and 2 point form, they are similar to each other. Y minus y1 equals to m into x minus x1, where m is the slope. The slope was directly given to us. But in 2 point form, the slope is not given. Instead, the other point is given. And we know how to measure the slope when both the points are given to us. So y minus y1 equals to m. The slope can be taken as y2 minus y1 by x2 minus x1 into x minus x1. So this is known as 2 point form. So when 2 points are given and we need to write the equation, we can take it as y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1, right? So 1 point and some other point. Let's say this point is B. The coordinates are x2 and y2. So we can take the equation of the line as given here, y minus y1 equals to y2 minus y1 by x2 minus x1 into x minus x1. Next comes the intercept form. Let us understand what is meant by intercept form of a line. Now we have already understood what is meant by intercept. In slope intercept form, the slope was m and the intercept was c. What is intercept? Intercept is the distance from the origin to the point where the line meets the given axis, right? For example, here the line cuts y-axis at this point. So the distance between origin and this point is c, which is known as the intercept. So in intercept form, both the intercepts are given. The intercept made by the line with x-axis and with y-axis. And we need to write the equation of the line. So let us understand, or let us see how the graph looks like. Let's say these are the x and the y-axis. And there is a straight line which is as shown here. Now if you see, the straight line cuts x-axis at one point and y-axis at another point. Okay, so here is the origin, and let's say the point where it cuts x-axis is A, and the point where it cuts y-axis is B. So what is the x-intercept? X-intercept can be taken as OA, right? We know that intercept is the distance between origin and the point where the straight line cuts the axis. So x-intercept, it cuts x-axis at A. So this distance OA can be taken as x-intercept. Likewise, what will be y-intercept? It will be equal to OB, right? From the origin to the point where the straight line cuts y-axis. Let us assume the distances are A and B, right? This is A and this is B. So the x-intercept is A and the y-intercept is B. So this is equal to A and here is B. So how do we get the equation of line intercept form? It can be taken as x by A plus y by B equals to 1. Alright, so when both the intercepts are given, we can write the equation of the line as x by A plus y by B equals to 1. So these are the different forms of equations of a straight line. Slope intercept form where the slope and intercept is given. So it can be taken as y equals to mx plus c. The slope point form where the slope and a point is given, which can be taken as y minus y1 equals to m into x minus x1. 2 point form, 2 points are given, alright, 2 points and the coordinates for both the points, right, x1 y1 and x2 y2. The equation can be taken as y minus y1 equals to y2 minus y1 by x2 minus x1, which is the slope, into x minus x1. And the last one here is intercept form, where both the intercepts are given, the x-intercept and the y-intercept. Equation can be taken as x by A plus y by B equals to 1. So these are the different forms of equations of a straight line. Now before we move ahead, let us take a special case of one of these forms, and that is the slope intercept form. We know that the equation of a line in slope intercept form is y equals to mx plus c, where m is the slope of the line and c is the y-intercept, that is the distance between the origin and the point where the line cuts y-axis. Now what happens if the y-intercept c is equal to 0? What do we understand when the y-intercept is 0? Let's look at this with the help of a simple graph. Let's consider the original graph here, right? These are the coordinate axis, x and y axis, and we know that there is an intercept, y-intercept, which is equal to c. And the line, as you see, passes through the y-axis and cuts it at a particular point. But if c is equal to 0, it is clear that the distance between origin and the point of intersection of the line with y-axis has to be 0, right? If C is equal to 0, means this gap between origin and the point of intersection should become 0. When is that possible? Only when the line passes through the origin. So the point to be noted is, if the y-intercept is 0, then we can conclude that the line passes through origin. And the equation of that line would become y equals to mx, since C equals to 0. Alright, so if C becomes 0, then the line passes through the origin. So this line can be taken as y equals to mx, since the y-intercept is 0. Understand, there is no other way that the line can cut y-axis. It has to cut y-axis only at origin. Hence the line passes through origin is the conclusion that we can make when C equals to 0. And the equation of the line becomes y equals to mx. Now, even if take at any other point, let's say if we assume that the straight line is as follows. Now in this case, what do we see? There is still a y-intercept, right? Understand, intercept does not mean that it has to be only on the positive y-axis or positive x-axis. Intercept is the distance of the origin, distance between the origin and the point where the line cuts the axis. Now here you see that this line cuts y-axis at this point. So the distance from origin to this point is considerable. There is some intercept, let's say C dash. Hence this cannot be y equals to mx. It has got a considerable intercept. Alright, so intercept is 0, means it will neither be cutting y-axis on the positive side nor on the negative side. So the only option possible is it has to pass through origin, and such a line can be taken as y equals to mx. So that's one special case which shows that the line passes through origin. Or when the equation is given as y equals to mx, we can conclude that the line passes through origin. And that applies even in the second form. If you look at the slope point form, it is y minus y1 equals to m into x minus x1. Slope and the point is given. In this case, as we have seen, the point is origin. Alright, so origin means what? y1 and x1 both are 0. So what do we get? Y minus 0 equals to m into x minus 0. So that again gives us y equals to mx. So clearly, if the line passes through origin, the equation of the line would become y equals to mx. And as and when the theta changes, right? Y equals to mx. The angle here is theta. Angle of inclination of the line with x-axis is theta. So as and when theta changes, the gradient or the slope, that is m, also changes. Equation will remain y equals to mx. Now that we have learned how to write the equation of a straight line in different forms, let us look at a few conditions. These conditions will help us decide if the given lines are parallel and perpendicular. So let's look at the statement here. Two lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So as we see, we have taken the equations in the general form. The general form, as we all know, is ax plus by plus c equal to 0, where a, b and c are the constants, right? So here in the first line, a1, b1 and c1 are the constants, and in the second one it is a2, b2 and c2 that are the constants. So these two lines are, point number 1, coincident. Now what does it mean by two lines being coincident? It means the lines lie on top of each other, right? So when you draw these two lines on the paper or on the graph, we will be able to see only one single line because both the lines are on top of each other, right? Not just lines, any geometrical shapes being coincident implies those two shapes lie on top of each other or are exactly the same. So the two lines are coincident if a1 by a2 equals to b1 by b2 equal to c1 by c2. Right, so the ratio of the coefficients a1 by a2, b1 by b2 and c1 by c2 has to be equal. Or we can say that the ratio of the coefficients of x should be equal to the ratio of the coefficients of y should be equal to the ratio of the constants c in both the lines. Point 2, the two lines are parallel if slopes are equal. Right, so that's easy to understand. If the slopes are equal, implies the lines are parallel. They have got the same inclination with respect to the positive x-axis. So if the inclination is same, obviously the two lines would be equal. So the two lines are parallel if the slopes are equal. Now what is the slope of line number 1? Minus a1 by b1, right? We know that the slope of a line can be taken as minus of the coefficient of x by coefficient of y. So minus a1 by b1. Now slopes have to be equal. So minus a1 by b1 should be equal to minus a2 by b2, right? Minus a1 by b1 equal to minus a2 by b2, which when further simplified gives us a1 by a2 equals to b1 by b2. So simply, if the ratio of the coefficients of x is equal to the ratio of coefficients of y, then we can conclude that the two lines are parallel. And this is when it is given in the form, in the general form. Let's say the equations of line are given in slope intercept form. y equals to mx plus c, right? So there are two lines, y equals to m1x plus c1 and y equals to m2x plus c2. So when do we say that the two lines are parallel? If m1 is equal to m2. Simply, the condition here is the slopes have to be equal, whatever be the form of the equation, right? So if the slopes are equal, the two lines are parallel. And finally, the two lines are perpendicular, right? What does it mean by lines being perpendicular? They intersect each other at an angle of 90 degrees, right? So the two lines are perpendicular if the product of the slopes is -1, right? The two lines will be perpendicular if the product of their slopes is equal to -1. So in the slope intercept form, y equals to m1x plus c1 and y equals to m2x plus c2. When do we say the two lines are parallel? If m1 into m2 equals to -1. But since we have taken the equations in general form, let's come to a conclusion here, right? The product of the slopes is -1. What is slope here? Minus a1 by b1. Slope in the second case, minus a2 by b2. This product has to be -1. When simplified further, we get a1 a2 plus b1 b2 equal to 0. So the point here is, we can now conclude saying that the two lines would be perpendicular if the product of the coefficients of x when added to the product of coefficients of y will result in 0, or simply remember a1 a2 plus b1 b2 equal to 0. But the basis of this condition is that the product of the slopes is -1. So simple points here, the lines are coincident if a1 by a2 equals to b1 by b2 equal to c1 by c2. Lines are parallel if their slopes are equal, and they are perpendicular if the product of their slopes is equal to -1. So before we take up questions based on straight lines, let us also learn how to measure the distance between a point and a straight line and the distance between two parallel lines. So the first one here is the distance of a point from a line. The statement says the length of a perpendicular from a point a x1 y1 to a line ax plus by plus c equal to 0 is given by modulus of ax1 plus by1 plus c divided by root over a squared plus b squared. So there is a point which is a of x1 comma y1 and a line which is given by the general form ax plus by plus c equal to 0. Now if you drop a perpendicular from the point to this straight line, or if you have to measure the distance between the point and the straight line, we take it as ax1 plus by1 plus c modulus of divided by root over a square plus b square, right? So how does it look like when you put it on a graph here? Let's say this is a straight line, right? This is the line described by ax plus by plus c equal to 0, and we have a point, point A. This is the point A, which is a of x1 comma y1. So when we have to measure the distance between the point and the line here, right, we drop a perpendicular. The shortest distance always is the perpendicular. So we just drop a perpendicular which is, as shown here, angle is 90 degrees. So when we drop a perpendicular, we get the distance between the point and the line as ax1 plus by1 plus c divided by root over a square plus b square. So this is the distance, right, from the point A. This is the point A to the point where it meets on the given line. So ax1 plus by1 plus c divided by root over a square plus b square. And be careful, the numerator has to be in modulus, which means we always take the positive value here. Distance cannot be negative, right? And the second point here is distance between two parallel lines, right? So if ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 are parallel lines, right? If these are two parallel lines, then the distance between these lines is given by modulus of c1 minus c2 divided by root over a square plus b square. So two lines expressed in the general form, ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. These two are parallel. Obviously they are parallel because the ratio of coefficients of x, a by a, is equal to the ratio of coefficients of y, b by b. Right? See, when the equations are given, it need not be exactly in this form. But when we try to simplify it, we'll find that the ratio of coefficients of x and the ratio of coefficients of y would be equal. Those two lines are parallel. So in that case, we only need to consider the constants c1 and c2 in the formula. So modulus of c1 minus c2 divided by root over a square plus b square will be the distance between these two parallel lines. As a special case, let us also see what will be the length of a perpendicular from origin to a given line. Here the point is x1 comma y1, but let's say we have to find out the distance between the origin and a given line. How do we measure it? It is given by the same formula, ax1 plus by1 plus c divided by root over a square plus b square. But x1 and y1 both are 0. Since the point is origin, the coordinates are 0. So if x1 is 0, ax1 becomes 0. y1 is 0, by1 also becomes 0. So what are we left with? C divided by root over a square plus b square. So we can also understand that the distance between origin and a line is given by c, or modulus of c, divided by root over a square plus b square. The next one here is distance between two parallel lines. So let's see how do we get the distance between two lines that are parallel. So ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 are two parallel lines. Alright, obviously they are parallel because the ratio of coefficients of x, a by a, is equal to the ratio of coefficients of y, b by b. A by a equals to 1, b by b equals to 1. See, when the question is given and the two equations of lines are given, it need not be equal. The ratio of coefficients of x may not be equal and the coefficients of y also may not be equal. But it is obvious that when we take, we can take something common in one of the equations to make sure that they become equal. Yes or no? Since the two lines are parallel, obviously the ratio has to be equal. So we can take common in one of the equations, some value common in one of the equations, such that the coefficients of x and y become equal. Now, when these two lines are parallel, then the distance between these lines is given by modulus of c1 minus c2 divided by root over a square plus b square, right? So c1 and c2 are the constants there in both the lines. So c1 minus c2, modulus of c1 minus c2 divided by root over a square plus b square. A and b are the coefficients of x and y in the two lines respectively, right? So modulus of c1 minus c2 by root over a square plus b square will give us the distance between the two parallel lines. And you very well understand that the distance between two parallel lines is always constant, right? Because the lines are parallel, they would never intersect, right? Their slopes are equal. So the distance remains constant throughout the lines there. Okay. So these points may be helpful in answering questions which are based on finding out the distance between a point and a line, or distance between two perpendicular lines. So simply substitute the values in the formula and you will get the right answer. And moving on to the last part of this session, where we shall learn about how to calculate the area of the triangle and some of its properties when the three vertices in the Cartesian coordinate system are given to us. Let's understand few of these points. So it says if a of x1 comma y1, b x2 comma y2 and c of x3 comma y3 are any 3 points, right? So as we see, these are 3 points in the coordinate system. The x and y coordinates for each of these points have been specified. So if these are the 3 points, then the area of the triangle ABC, the area of the triangle formed by these 3 points ABC, will be given as half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So simply substitute the coordinates in the formula here to get the area of the triangle ABC, right? Half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, right? And remember, sometimes we may get a negative value when we simplify this formula by substituting the given values. But since the area cannot be negative, we just need to take modulus of that given value, or simply consider the magnitude as the area of the given triangle ABC. Then next point here, it says the points A, B and C are collinear if. So the points A, B and C, the 3 points here are collinear. What does it mean by points being collinear? When we say that 3 points are collinear or a given number of points are collinear, it indicates that all the 3 points lie on the same straight line. Alright. So the 3 points A, B, C are collinear implies A, B and C are on the straight line, right? They are forming a single straight line. If the area of the triangle ABC equals to 0. Yes or no? That's obvious. If the triangle is 0, if the area of the triangle is 0, it indicates that the 3 points are on the straight line. Only when they are not in a straight line, we can make some triangle out of it and find out the area, right? There will be some considerable area. But when the area is 0, it's clear that the 3 points are on the same straight line, and hence we can conclude that the points are collinear. Or there's another way to verify if the points are collinear or not. What is that? The slope of the line AB should be equal to slope of AC. Slope of the line AB should be equal to slope of the line AC, or the slope of the line passing through the points A and B will be equal to slope of the line passing through the points A and C. Yes or no? What is slope? Slope is the tangent of the angle, tan theta, where theta is the angle made by the line passing through the 2 points with respect to the positive x-axis. So the angle made by the line passing through A and B is equal to the angle made by line passing through the points A and C. So it's obvious that A, B and C are in a straight line. If their slopes are equal, it's clear that the 3 points are in a straight line. Right? And this second condition here also shows that if the slope of AB is equal to slope of AC, then out of the 3 points, 1 point lie on a line which passes through the other 2 points. For example, let's consider a line passing through A and B. If the slopes are equal, implies the point C is on the line passing through A and B. Likewise, if we consider the line passing through A and C, then the point B will be on the line passing through A and C. And if we consider the line passing through BC, the 2 points B and C, then the point A has to be on that line which passes through B and C. So there are different ways of verifying if the given points are collinear, right? Simply the area of the triangle ABC should be 0, or the slope of the line passing through A and B should be equal to the slope of the line passing through A and C. Moving on to the next point, the centroid of the triangle ABC is equal to x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So here the coordinates of the centroid of the triangle can be taken as x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So that's basically the average of the coordinates of the points A, B and C. By the way, what is meant by centroid? Centroid is the point of intersection of medians of the triangle ABC, right? It is the point of intersection of medians of the triangle A, B and C. And what is a median? Median is a line joining a vertex of a triangle to the midpoint of the opposite side. Alright, so we'll have 3 medians in a triangle, and the point of intersection of these 3 medians is called as centroid. Basically, this is the point where the entire weight of the triangle is concentrated, and it can be calculated as x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So that's a very simple calculation. And the next point here is about circumcenter, right? The circumcenter of the triangle ABC, if it is taken as O of x comma y, then OA will be equal to OB will be equal to OC. What is meant by a circumcenter? Circumcenter is the point of intersection of the perpendicular bisectors of the sides of the triangle. Right? It is a point of intersection of the 3 perpendicular bisectors that we get for each of the sides of the triangle. So from this point of intersection, if we draw a circle, it will touch all the 3 vertices of the triangle. Right? Such a point is known as circumcenter. So this is basically the center of a circle which touches all the 3 vertices of the triangle. And it's obvious that if it touches all the 3 vertices of the triangle, from this center to each of the vertices, the distance has to be equal. Right? So if the center of circumcenter is O and the 3 vertices are A, B and C, then the distance OA should be equal to the distance OB should be equal to the distance OC. Basically the radius of the circle there, which is actually known as circumradius in this case. Right? So simply circumcenter is, as you know, the point of intersection of perpendicular bisectors. Right? So from this circumcenter, when we draw a circle, it touches all the 3 vertices, which implies that the distance from circumcenter to each of the vertices has to be equal. So we come to a conclusion that OA will be equal to OB will be equal to OC. Now we very well know how to calculate the distance between 2 points. Root over x1 minus x2 whole square plus y1 minus y2 whole square. Right? So we can just take these 3 equations. O is x comma y, we know what is x1, y1, x2, y2, x3, y3. So we'll get different equations here, and by solving them, we'll be able to find out the circumcenter, right? And the point to be noted here is that since the 3 distances, OA, OB and OC are equal, the squares of these distances should also be equal, right? So we can say that OA square equals to OB square equals to OC square, right? How do we measure the distance between 2 points? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. So to get rid of that square root, we can take the square of each of these distances. So when we simplify this equation, we will be able to find out the coordinates x comma y, right? What do we get basically? If you take OA, what is the distance OA? OA is x comma y, A is x1 comma y1. So we can say x minus x1 whole square plus y minus y1 whole square, right? This is OA square. OA will be root over this. So when we have taken OA square, we get x minus x1 square plus y minus y1 square. This should be equal to what? OB square. Now what is OB square? X minus x2 square plus y minus y2 square. And this should be equal to OC square. OC square is x minus x3 square plus y minus y3 square. So by simplifying this, we will be able to find out the coordinates of the circumcenter O of x comma y. And the last point here, in center, right? The in center I of x comma y can be taken as ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. Now, let us first understand what is an in-center. I am sure all of you understand that in-center is the point of intersection of the internal bisectors of the angles of the triangle. Right? It is the bisectors of the angles of the triangle. So we get three internal bisectors, and the point of intersection of all these three bisectors will give us the in-center. So from this in-center, when we draw a circle, it will touch all the three sides of the triangle. Unlike circumcenter, from which if we draw a circle, it touches all the three vertices. But in-center, from the in-center, if we draw a circle, it will touch all the three sides of the triangle. Okay. Now, as given by the formula, the coordinates of the in-center can be taken as ax1 plus bx2 plus cx3 by a plus b plus c, and ay1 plus by2 plus cy3 by a plus b plus c. We very well know what is x1, x2, x3, y1, y2, y3. These are the x and y coordinates of the 3 points a, b, c. But what are these small a, small b and small c in the formula? It is nothing but, if you look at a is equal to the distance between the points BC, right? Basically, we have a triangle ABC. So in that triangle ABC, the length of the side BC is equal to A. How do we measure the length of the side BC? Nothing but the distance between the 2 points B and C, which we know how to calculate, right? The distance between the 2 points B and C can be taken as root over x2 minus x3 whole square plus y2 minus y3 whole square. So small a is the length of the side BC. Likewise, small b is length of the side CA, and small c is length of the side AB. So when we have the triangle ABC, where the three vertices are given, we first need to calculate all the three lengths of the sides, right? A, B and C. And then use this formula, ax1 plus bx2 plus cx3 by a plus b plus c, and ay1 plus by2 plus cy3 by a plus b plus c to get the in-center of the triangle. So this is about the area of the triangle and some of its properties, basically the centroid, circumcenter, in-center and so on. Generally, in competitive exams, questions based on circumcenter and in-center of the triangle are not asked. But however, it's always good if you remember the formula so that you are prepared for any surprises if we get in the future exams. However, questions based on area of the triangle and points being collinear and centroid of the triangle are common. So make sure that you remember each of these formulae and apply them effectively so that you can get the required answer without any difficulty. Let us now take the first example from the last model, model 4 of coordinate geometry, where we shall discuss a few questions based on triangles. Let's look at the first one. Example 1, it says find the area of the triangle formed by the points obtained by the equations x equal to 4, y equal to 3 and 3x plus 4y equal to 12. And we need to find out the area in square units. We have 4 answer options here. Option A 10, option B is 12, option C is 6 and option D is 8. Right? So we have been given 3 equations. X equal to 4 is the first equation, y equals to 3 is the second equation, and 3x plus 4y equal to 12 is the third equation. Now these 3 equations are nothing but 3 straight lines. So when these 3 straight lines intersect at different points, we get 3 vertices, right? And those 3 vertices will give us the area of the triangle, right? With the help of those 3 vertices, we can find out the area of the triangle. We have already learned that the area of the triangle, when the 3 vertices are given, can be taken as half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. But the challenge in this question is those vertices have not been given directly. Instead, we have been given the equations of those 3 straight lines. So we need to solve these equations, get the 3 vertices and then substitute the values in the formula to get the area of the triangle. So that's one way of answering the question. What do? Solve the equations. We have got 3 different equations here. By solving them in pairs, we'll get 3 different vertices, right? Those 3 vertices will give us the area by using the formula. Otherwise, since the equations here are easy to interpret, right? X equal to 4. X equal to 4 is a straight line which is parallel to y-axis, right? Y equals to 3 is a straight line parallel to x-axis. And 3x plus 4y equal to 12 is also a easy one to understand, right? It can be taken in the intercept form. And we can easily identify the area of the triangle by just drawing these 3 lines on the coordinate axis. So let's try out with the help of a simple graph. What do? Just take the coordinate axis and see what the 3 vertices are. The first equation is x equal to 4. What does it mean by x equal to 4? This is the x-axis, right? And here we have got the y-axis. x is equal to 4. Let's say x is 4. X is 4. If x is 4, y coordinate is 0. So this is one of the lines, right? This is one straight line. This is x equals to 4. What's the other line? Y equal to 3, right? Y is equal to 3. Draw y equals to 3. Let's say this is 3. So if y is 3, x would be 0. So the point here is 0, 3. So this line would be parallel to x-axis, right? So this line is y equals to 3. Right, so one equation x equal to 4 has given us a line parallel to y-axis. The other equation y equal to 3 has given us a line parallel to x-axis. And now look at 3x plus 4y equals to 12. 3x plus 4y equals to 12. Let's convert this into intercept form, right? So 3x plus 4y equal to 12. 3x plus 4y equals to 12 can be taken as x by 4 plus y by 3 equals to 1. Dividing both the sides by 12. So 3x by 12 is x by 4. 4y by 12 is y by 3. 12 by 12 is 1. Now x by 4 plus y by 3 equals to 1. This is clearly the intercept form, right? Intercept form of the equation of a straight line. What does it mean? This line x by 4 plus y by 3 equals to 1 makes an intercept of 4 units on x-axis and intercept of 3 units on y-axis. Basically x intercept is 4, y intercept is 3. So let's draw this line now. X intercept is 4. X intercept is 4 means what? The point where the line cuts x-axis will be 4. Right? So same point 4, 0. And y-intercept is 3. That means the distance from origin to the point where the line cuts y-axis is 3. Yes or no? We have already learned this. Intercept is nothing but the distance between origin and the point of intersection of the line with the axis, coordinate axis. So since x-intercept is 4, distance from origin to the point of intersection should be 4. Y-intercept is 3. So distance from origin, right? This is the origin here. Right? This is the origin. So from origin to the point where the line cuts, the distance has to be 3. Now draw a line. How do we draw this line? See, it cuts y-axis at this point and x-axis at this point, since the intercepts are 3 and 4 respectively. So draw a line now. This is the line. What line is this? 3x plus 4y equals to 12. Now, what are the three vertices? Look at it. What is a triangle? This is one of the lines, x equal to 4. The second line is y equal to 3. And the third line, 3x plus 4y equal to 12. So what is a triangle? This is the triangle that we get. Yes or no? These three lines, if you observe, is forming the triangle this way. Now, what are the three vertices? One of the vertices is 4, 0 clearly. The other vertex is 0, 3. What about this one? What is this point? Easy to identify, right? See, the distance from y-axis is 4. The horizontal distance is 4. And the vertical distance, what's the vertical distance? 3. So this point can be taken as 4, 3. So these are the three vertices, 0, 3, 4, 0 and 4, 3. Now that we have the three vertices, we can use the formula half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Right? Just substitute the three coordinates, right? Three ordered pairs there. But if you look at the given triangle, the shaded region here, it is clearly a right angle triangle, right? Since we have two perpendicular axes. This line is parallel to y-axis and the line here is parallel to x-axis. So clearly if two lines are parallel to x-axis and y-axis respectively, the point of intersection will be the right angle, right? This is a right angle triangle. How do we get the area of a right angle triangle? Half into base into height, right? Let's take this is the base. So what is this length? What is this length? From 0 to 3. 3 units. Right? If this is the base. What is the height? This is the height, let's say. Right? Or we can consider this as the base and this as the height. Nothing wrong with that. So what is this distance now? From 0 it is 4. So 3 units and 4 units. Half into base into height. Area of the triangle or area of a right angle triangle is half into base into height. Just substitute the values. So half into the base is 3, let's say, and the height is 4. Or otherwise the base is 4 and the height is 3. Gives us the same answer, right? What happens? This goes 2 times 3 into 2, 6 units. So the area of this triangle will be option C, 6 units. Again, understand that because I am explaining in a detailed way by drawing all these lines, it takes so much time. But if you are smart enough, you can quickly understand what are the three vertices and find out the answer using the area of right angle triangle formula, right? So that's one way of solving this question. And remember, we have followed this method because the equations were very easy to draw. X equal to 4, y equal to 3, and this was also in intercept form. right? If the equations are not so easy to draw, right? If all the three equations are in the form of ax plus by plus c equal to 0, then how do we get the answer? Then we'll have to find out the points of intersections, right? For example, equation number 1 and equation number 2, solve. By solving, we'll get the values of x and y. That is one of the vertex. Then equation 2 and equation 3. By solving equation 2, equation 3, we'll again get x and y. That is the second vertex. And solving equation 3 and equation 1, we get the third vertex. Once we get the three vertices, we can find out the area. Let's solve this question in the other way as well, the regular method, right? If three equations are given, how do we do, right? Anyway, we know the answer is 6 units, which is option C. But let's see, how do we solve the three equations? Now, if you look at equation 1, see, this is our equation 1. This is equation 2 and equation 3. Now, if you look at equation 1 and 2, what are equations 1 and 2? Equation 1 says x equal to 4. Equation 2 says y equals to 3. So I can say that the vertex A, x comma y, is equal to 4 comma 3. Directly we know the values, right? Or we can take x1 y1. x1 y1 is 4 comma 3, right? By solving, there's nothing to solve. Directly the values are given. Now let's solve equation 2 and equation 3. What happens? Equation 2 and equation 3 we solve, right? Let's say this is vertex B, x2 y2, x2 y2, right? Now solve 2 and 3. What happens? Equation 2 clearly says y is equal to 3. So we know that y is 3. What we have to calculate is x here. How do we calculate x? Substitute y equals to 3 in this place. What do we get? 4 into 3, 12. 12 minus 12, 0. X will be equal to 0. X is 0. 0 comma 3 is the second vertex. And how do we get the third vertex? Solve the third pair of equations, equation 1 and equation 3, or equation 3 and equation 1, right? Now look at equation 1. It directly says x is equal to 4. So the third vertex, which is x3 y3, let's say c of x3 y3, we know that the value of x is 4. It is directly given there. Now if x is 4, how much is y? Substitute x equals to 4 here. 3 into 4, 12. If this is 12, y has to be 0. So 4 comma 0. So we have got the three vertex A, B and C. Now that we know the three vertices, we can find out the area of the triangle. So if it is not so easy to plot and get the answer, you can follow this method. And in cases where the equations are not so easy to draw, as I mentioned, right, ax plus by plus c form, if that form is given, then we'll have to solve the equations to find out the three vertices. Once we get the three vertices, you can do all the different types of questions, right, be it based on area of the triangle, or in center of the triangle, or centroid of the triangle, or circumcenter of the triangle. Let us now take another example based on finding out the area of the triangle when the three equations are given. The question says, find the area of the triangle formed by the lines 5x plus 7y equals to 35, 4x plus 3y equals to 12, and x-axis. And the area here has to be calculated in square units. The options are 160 by 13, 150 by 3, 140 by 3, and 10. And let me also tell you that this is one of the earlier SSC CGL exam questions. So like in the previous case, here we have been given three equations. First one is 5x plus 7y equals to 35. The second one is 4x plus 3y equals to 12. And the third one is x-axis. So three equations here represent the three lines. So when we find out the points of intersections, we get the three vertices, and then we can get the area. Alright. Now, equation number 1 and equation 2 are clearly specified. 5x plus 7y 35 and 4x plus 3y equals to 12. But look at equation number 3. It says, find the area of the triangle formed by these lines and x-axis. Well, x-axis is also a line. But how do you define x-axis? What is the equation of x-axis? Y equals to 0, right? We have learned this earlier. The equation of x-axis is y equals to 0, right? Likewise, the equation of y-axis is x equal to 0. Why do we say equation of x-axis is y equal to 0? Because on x-axis, the y coordinate is equal to 0 always. So now, if you look at the question, we have got three equations. 5x plus 7y equals to 35, 4x plus 3y equals to 12. And instead of calling it as x-axis, let's say y equals to 0. Three equations. Find out the points of intersections and then get the area, right? So let's say this is equation number 1. Here we have equation 2, and equation number 3 is x-axis, which is y equals to 0, right? So let's solve equation 1 and 2, right? Equations 1 and 3, let's say equation numbers 1 and 2 first, right? 1 and 2, equation numbers 1 and 2, right? What do we get? 5x plus 7y equals to 35. and 4x plus 3y equals to 12. 4x plus 3y equals to 12. Understand, why are we not going ahead with plotting these lines on the graph? We can do that. This can be expressed in the intercept form, right? X by 7 plus y by 5 equals to 1. Even this can be expressed in intercept form. X by 3 plus y by 4 equals to 1. But the point is, though we know the x and y intercept, we cannot find out the point of intersection directly from the graph. We have to solve the equations. So there is no point in drawing these lines on the graph and wasting our time. Just go ahead and find out the vertices. So we are solving equations 1 and 2 now. 5x plus 7y equals to 35 and 4x plus 3y equals to 12. You very well know how to solve linear equations, right? Let's try to make the coefficients of x equal. So we'll multiply equation number 1 with 4 and equation number 1 with 2 with 5. So this will be equal to 20x plus 28y equals to 140, and from this we get 20x again plus 3 into 5 15y equals to 12 into 5 60. So upon solving, what do we get, right? X and x anyway gets cancelled, 20x and 20x. 28y minus 15y is 13y. 13y equals to 140 minus 60 is 80. So we can say y is equal to 80 by 13. So the y coordinate of the intersection of these two lines is 80 by 13. Now that we have got y equals to 80 by 13, we can substitute this value in any one of the equations and we will get the value of x, right? So substitute y equals to 80 by 13. Let's substitute in equation number 1. So what do we get? 5x plus 7 into 80 by 13 equals to 35. So from this we can say, see if we take 5 common, so 5 ones, 5 into 16 and 5 into 7. Alright, so we can say x will be equal to 7 minus 7 into 16, right? What is 7 into 16? It will be 70 plus 40 to 112, right? 112 divided by 13. Or for the simplification we'll give 7 into 13, right? Which is 91, right? 91 minus 112, which is minus 21, minus 21 by 13, right? 91 minus 112 is minus 21 by 13. So the x coordinate is minus 21 by 13. So with this we have got both the x and y coordinates. So we can say that the first vertex, right, by solving equations 1 and 2, we have got the first vertex, let's say a, which is equal to minus 21 by 13, and the y coordinate 80 by 13. Let us now solve the other equations, right? Equation number, equation numbers 2 and 3. Equations 2 and 3, right? What is equation 2 here? 4x plus 3y equals to 12. Equation 3, y equal to 0. I think this should be easy to solve. Since we know that y is directly equal to 0, we can say here the vertex B will have the ordinate equal to 0. The y coordinate equal to 0, right? Y equals to 0. Substitute y equal to 0 here, what do we get? 4x equal to 12, which means x equals to 3. That's the vertex, right? So that's like again solving the equations, but very easy to solve since we know one of the coordinates. Likewise, equations 3 and 1. You need not write all these steps in the exam. You can cut down the number of steps. I'm just trying to give you the detailed solution, right? Now if you get the third vertex, equation 3 and 1. Again we know y is equal to 0, right? Y coordinate is 0. Substitute 0 here. So 5x equals to 35. X will be equal to 7. That's it. So these are the three vertices. Minus 21 by 13, 80 by 13, 3, 0, 7, 0. Now that we know the vertices, just substitute the values in the formula. What is the formula? Half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, right? So we can say, let me just clear the other part here. So I think the three vertices are minus 21 by 13, 80 by 13 is one of them, and the others are 3, 0 and 7, 0. Now let's substitute the values in the area of the triangle formula. So the area of the triangle ABC will be equal to half of, right, x1. What is x1? Minus 21 by 13. x1 into y2 minus y3. y2 minus y3. y2 minus y3 is 0. Plus x2. What is x2? 3. x2 into y3 minus y1. So 0 minus y1 minus 80 by 13 plus x3. What is x3? 7. 7. x3 into y1 minus y2. What is y1? 80 by 13 minus 0. 80 by 13 minus 0. That's it. So this anyway is cancelled, right? 0. Now 3 into minus 80 by 13 plus 7 into minus 80 by 13, right? Simplify this. So half of 3 into minus 80 by 13 plus 7 into 80 by 13. So again, if we take 80 by 13, what do we get? 7 minus 3, right? This can be taken as minus 3 into 80. So 80 by 13 is common, 7 minus 3 is 4. So this will be equal to half of 4 into 80 by 13. This goes 2 times. So finally we can say the answer is 160. 2 into 8 is 160. 160 by 13, right? 160 by 13 is option A here, right? So this gives us the area of the triangle, 160 by 13. So I know finding out the vertices would take some time, but if you are very quick in solving the equations, it wouldn't be difficult, right? So quickly get the vertices of the triangle, all the 3 vertices of the triangle there, and substitute in the formula to get the required answer. Let us now take the next one from model 4. Example 3, it says a triangle is formed by x-axis and the lines 2x plus y equal to 4 and x minus y plus 1 equals to 0 as the 3 sides. Now taking the side along x-axis as its base, find the corresponding altitude of the triangle. Alright, so we have been given how the triangle is formed, right? The triangle here is formed with the help of x-axis and the 2 lines 2x plus y equal to 4 and x minus y plus 1 equal to 0. Now it says we have to consider the x-axis as base of the triangle, right? If x-axis is the base of the triangle, what is the corresponding altitude? Altitude or the height of the triangle. So let's see how to get the answer for this one. Now first and foremost, we need to know the vertices of the triangle, the 3 vertices of the triangle. So let's quickly find out the 3 vertices there. X-axis is y equals to 0, right? We know the equation for x-axis is y equal to 0. So if y is equal to 0, we are finding out the first vertex, right? Which is nothing but the point of intersection of y equal to 0 and this line 2x plus y equal to 4. So if I can say the first point here is A, let's say the first point is y equals to 0 anyway. If y is 0, x will be equal to 2. Alright, then let's take the point of intersection of y equal to 0 and x minus y plus 1 equal to 0. So the second point will be again y is equal to 0, and if y is 0 we get x equals to minus 1. Now the third point will be the intersection of these 2 lines 2x plus y equal to 4 and x minus y plus 1 equal to 0. So let's solve those 2 lines. 2x plus y equals to 4, 2x plus y equals to 4, and this is x minus y equals to minus 1. Let's say x minus y equals to minus 1. So solve, plus y and minus y gets cancelled. We say 3x equals to 3, which implies x equals to 1. So x is 1. Now substitute back in the equation to get the value of y. X equals to 1. So 2 plus y equals to 4, which means y equals to 2. Right? So x is 1, y should be equal to 2. Likewise, we can substitute here as well. 1 minus 2 will give us minus 1. So what is the third coordinate? 1 comma 2. Right? The third coordinate. Let's say C is equal to 1 comma 2. X equals to 1 and y equals to 2. So now we know the 3 coordinates. So as you see, this is how we just need to quickly find out the 3 vertices of the triangle. Right? We need not write every set of equations there. If you are smart enough, you can easily do that by cutting down a few steps. Now let's try to understand this with the help of a graph. If you are clear with how the triangle looks like, you can directly say that the altitude of the triangle is going to be 2 units, right? The y coordinate of the vertex C. But for those who are not able to follow, let me just show this on the coordinate axis. So this is our xy plane, right? Now, what is the first point? 2 comma 0. This is point A, let's say, right? Point A. 2 comma 0, y equals to 0, x equals to 2. What is the second point? Minus 1 comma 0. Now this is origin, right? This is origin. Minus 1 will be on the left side. So let's say this is B, which is minus 1 comma 0. Now look at the third point, 1 comma 2. The third point C here is 1 comma 2. That means x is equal to 1, y equals to 2. So somewhere here, approximately, right? X is 1. So it should be before 2, right? X equals to 2 here. This is 2. So this should be 1, let's say. And y is equal to 2. So kind of intersection of these 2 lines, right? This is 2 and this is 1. X equals to 1, y equals to 2. What do we get? The third point C, right? What is the point C? 1 comma 2. Now these are the 3 points A, B and C. The question says we have to consider the x-axis as the base. What is x-axis? This is x-axis. So this should be base. AB should be the base. First let's draw the triangle. This is how the triangle looks like, right? A, B and C. Now AB is the base. X-axis is the base. Find the corresponding altitude of the triangle. Altitude is nothing but the height of the triangle. Now if this is the base, what is height of the triangle? This is going to be the height of the triangle, right? This is height of the triangle, right? This height h. Now this height h is nothing but the vertical distance, vertical distance of point C, right? This is nothing but point C which has got the coordinates 1, 2. Height of the triangle is the vertical distance of point C. What's the vertical distance of point C? 2 units. Yes or no? Vertical distance. Vertical distance is the distance from x-axis, which is nothing but y coordinate, 2 units. So we can say that the corresponding altitude or the height of the triangle will be 2 units. Right? So if you have this graph in your mind, if you can visualize this, you can directly say that 2 units will be the answer. Alright? The height is going to be 2 units. Because these 2 points lie on x-axis, that's the base. C will be above the base, right? And C has got y coordinate equal to 2, which is its vertical distance. And height is nothing but the vertical distance from the base. So 2 units is the answer for this question. And now, with the help of same 3 vertices, let's see what is the circumcenter of the triangle. The question has already been solved. Answer is 2 units. That is, the corresponding altitude of the triangle is 2 units. But we are just trying to understand how do we get the circumcenter of the triangle when the 3 vertices are given, right? So let's just clear the remaining part of the question here. So let's say the circumcenter is given by the point O, and we need to calculate the ordered pair xy, right? That is nothing but the coordinates of the circumcenter. Now we know that if the circumcenter is O, the distances OA, OB and OC are all equal, right? A, B and C are the vertices of the triangle, and since the circle that we draw from the circumcenter passes through all the 3 vertices, it is clear that OA, OB and OC has to be equal, and we have already taken this point in our earlier discussion. So all we need to do here is substitute these values, form the different equations and solve for x and y, right? Let's consider OA equals to OB, right? Or we can also say OA squared equals to OB squared equals to OC squared, right? Now what is OA? Right, how do we measure the distance? OA is nothing but x minus x1 squared plus y minus y1 squared equals to OB. OB can be taken as x minus x2 squared plus y minus y2 squared, where A is x1 y1 and B is x2 y2, let's say, right? And we are not taking under root because we have already considered the squares of the distances. Now solve this, we get x minus 2 squared plus y minus 0 squared equals to x minus of minus 1, right? So we get plus 1, x plus 1 squared plus y minus 0 squared. Right, so clearly y squared gets cancelled on both the sides. So what are we left with? X minus 2 squared equals to x plus 1 squared. So this implies x squared minus 4x plus 4 equals to x squared plus 2x plus 1, right? Just using a plus b or a minus b the whole square expansion. So x squared anyway gets cancelled. We get 6x equals to 3. 6x equals to 3 implies x equals to 1 by 2. So by solving OA square equals to OB square, we have got the first coordinate, x coordinate 1 by 2. Likewise, by solving some other equation, let's say OB square equal to OC square, we can calculate the y coordinate of the circumcenter. So let's find out the y coordinate now. X equals to 1 by 2. Let's consider the second part now. OB square equals to OC square. So what do we get? OB square equal to OC square? X minus b is minus 1, right? So x plus 1 whole square plus y minus 0 squared equals to OC square. So again, x minus 1 squared plus y minus 2 squared. So this equation here corresponds to OB square equals to OC square. And now that we have already got the value of x equals to 1 by 2, we can directly substitute x 1 by 2 in this equation and find out the value of y. So 1 by 2 plus 1 whole square plus y square should be equal to 1 by 2 minus 1 whole square plus y minus 2 whole square, right? Y minus 2 whole square can be expanded as y square minus 4y plus 4. So again we see that y square anyway gets cancelled on both the sides. 1 by 2 plus 1. 1 by 2 plus 1 is 3 by 2. 3 by 2 square is 9 by 4. 9 by 4 equals to, this will be minus 1 by 2 whole square. Minus 1 by 2 whole square is 1 by 4 plus 4 minus 4y. So from this we get 4y equals to 2, which implies y equals to 1 by 2. So the y coordinate of the circumcenter is also 1 by 2. So hence we can say that the circumcenter of the triangle here is 1 by 2 comma 1 by 2. So this is how, simply by using the identity OA square equals to OB square equals to OC square, where O is the circumcenter and A, B, C are the 3 vertices of the triangle, we can find out the coordinates of the circumcenter. So with this question, we come to the end of this topic of coordinate geometry. Just make sure that you remember all the different forms of equations of straight line, the formula for finding out the distance between 2 points, section formula, and the formula related to area of triangle and finding out its circumcenter, incenter, and centroid of the triangle, so that we can answer the questions in the exam without any difficulty. See you in the next session. Thank you.